You see now the linear regression. So the linear regression is something that we run when we want to see how much one variable affects the other. And to run the linear regression, I have to do this. So these are my data, and I want to see how much training hours affect the kilometers that I run in a marathon or during my training. So I go to regression, I click on linear regression. As dependent variables, I put my kilometer run, and covariates, I put my training hours. And here you have directly straight the result. So we have the R squared that tells us how much the variability of one variable affects the other. So how much the variability of kilometers run is explained by the training hours. And here you have your intercept, which is 105, and here you have your slope. Remember that the intercept in this case is the number of kilometers that I run when I do 0 training hours, and this is the slope, 0.932, which is how many kilometers I run every time that I increase my training hours by 1. As you can see, both of them are significant. That means that in this case the training hours affect the kilometers run significantly. Okay. Let's say now that I want to see and hypothesize what happens if I train 20 hours. How many kilometers I would run. So I have to do this simple operation. I just take my intercept, which is 105.347, and I add up my slope, 93, multiply by the number of training hours that I wanna check. Now you do the calculation, and by solving this equation, you will have the hypothetical kilometers run that you will do if you train 20 hours. Okay? Sorry. Now, let's see, we can see other things in the linear regressions. So as we saw earlier, we can have our descriptive statistics and have the mean and the standard deviation. We can again check for the normality of the data, and data, as you can see here, are normally distributed because I have Shapiro-Wilk test that is 0.98 and the p-value is higher than 0.05. I can make basic plots, so I can check again the QQ plot. As you can see here, well, these are not very well distributed, especially the training hours, as you can see here. But the Shapiro-Wilk test tells us that they are normally distributed. The p-value is very low. It's close to 0. It's more close to 0.05 than the p-value of the kilometer run, and you can see it here because they're distributed a bit far from the center of this line, but it's still okay. You can make a box plot for each variable. You have the training hours and the kilometers run. Okay. You can, well, the violin plot is something that is not used that much. Okay. I would avoid doing that, even though it's nice to see, but it's not good. You can make a scatter plot because in this case you have both variables, and the relationship here, the regression line in the scatter plot, should be linear. Okay, because this is what you're doing, the linear regression. Okay, and these are the distribution of your two variables. So you have the independent variable here and the dependent variable on the y-axis. Okay, that's it.